Good afternoon. We will be starting now, and I want to let everyone know that we're going to be recording this session so that it will be available for those who were unable to join this morning or this afternoon, depending on where you are. So welcome to the second CEDS Masterclass. Behind every informed data user is a great CEDS tech stack. My name is Nancy Copa, and I'm with the CEDS team. In case you missed it, our first session was 2 weeks ago, the cornerstone of CEDS U. We do have the webinar available, and I do want to do just one quick poll here, so everybody can kind of get ready. About, did you attend or watch the recording of the masterclass number 1 that was held on November 17th? So if you can go ahead, just very quickly, click yes or no and submit. Give you just another minute. Not quite a minute. Okay, great. So it looks like about 75% of you attended the first session. So for those of you who did or watched the recording, welcome back. We appreciate it. For those of you who were not able to join us last time, but are interested, here is the link to the recording. So you can go back and watch that at any time. Today, however, so last time we talked about how you can get involved in CEDS and what are those touch points. But today we're going to talk about the CEDS tech stack. So we're going to go through first the website tools of Align and Connect. Then we'll move on to the GitHub tools such as the integrated data store, the data warehouse, Parquet files, and our new ontology. Then we are going to shift and have our lead architect talk about several CEDS implementation options, ways that you can set up your system to best utilize CEDS and all of its resources. And then finally, we're going to wrap up because there are a number of challenges, whether you are a state, an LEA, an early learning provider, a post-secondary institution, or someone at the state in early learning or post-secondary, wherever you may be, there are challenges with data that CEDS can help with. So we're going to go over quite a few of those challenges, and if you're facing those challenges, kind of what are those specific tools or resources that you might want to utilize to help you. So that is the agenda for today. Now, I want to pause for a moment. We did this on the last masterclass and asked about your familiarity with CEDS. And this really helps us tailor the conversation to make sure that we're covering at your level. We do have plans to cover everywhere from the novice to the master, but you'll see now on your screen a second poll just to kind of find out where we are so we know kind of where to tailor that information for today. And I'll give you about 30 more seconds for that. Okay, great. So it does look like we have folks from all the way through from beginner to master, and that's great. We do have information, like I said before, that's going to span all of that. So it's this should work out. That you should be able to glean something from this presentation, no matter what level you are at. So today, I mentioned my name is Nancy Copa. I'm with the CEDS team. And I'm joined today by Dwayne Brown and Emily Rang, who both were on the first CEDS Masterclass. So if you were able to watch that, then you'll recognize them. And in addition to that, we are joined by our other CEDS team members, Liz Burnett and Nathan Clinton. So let's get started with the website tools. Okay, last poll. Sorry, but we want to make sure this is an interactive session. 90 minutes is a little bit of a long time. So last poll here. I want you, if you have used any of the CEDS tools or resources, no matter what it may be, to go ahead and drop that in the poll. It's going to generate one of those word clouds, but just kind of want to see what folks have been using or may have, kind of tapped into a little bit. So just go ahead and drop that, and I'll give you maybe about a minute to do that. And you should be able to submit multiple responses. I haven't really done one of these word cloud polls before, so hopefully that is true, but we'll see. All right, I'm going to give you about 30 more seconds to get those answers in. Okay. All right, thank you. So you can take your hands off the keyboard now. We're good there. I'm going to go ahead and close that poll. I have to say my favorite resource that I'm seeing up here is Nathan and Johnny and Dwayne Brown. They are a fabulous resource or set of resources, so I don't blame you for counting them. So that's great. I kind of figured that Align would be the biggest one on here because that's the starting place for a lot of people, right? It's the tool that's been around the longest. It came out in 2011. So it's been there the longest. As CEDS has evolved, some of these others that you all are mentioning have been added on later. So this is great. It looks like we have folks from using all over. So what we're going to do now is we're going to switch to the website tools and talk a little bit about Align. So Align is, for those of you that don't know, is a free online data management tool. What that means is that you can take your data dictionary, or where you may have stuff in a lot of different places, you can build a data dictionary using Align, and you can then compare that with other data systems dictionaries, okay? So anybody else that's used Align, whether it's one that they've shared publicly, or maybe you build one for multiple different systems that you have in your affiliation. So you can use it for that. It does support data governance. Align has available fields for you to put in who your data steward is, who your internal contact is, right? So that may be a program person, or it may be an IT person. The data steward is usually a program person. So you can have all of that information in there. If it is shared publicly, your map, which is what Align data dictionaries are called, they're called maps. So if your map is shared publicly, that information does not get shared out. Only you will be able to see it, and those that you have added directly to your map and given them access to view that information. So if you do use it in that sense for your data governance to be able to track that kind of information, just know that that's not going to be showing up publicly when you share it. It is also used for transparency. I probably don't have to tell all of you about the importance of transparency because you are dealing with education data, but for legislators, researchers, parents, students, if you're post-secondary, anybody like that, to understand what data you might be collecting, how it's defined, all of that is available by using the Align maps. As far as data system integration, if you're doing data system integration, Align is a great place to start. You have the ability to align multiple data systems and then run a report to compare them. And the reason you might want to do that is you can see what elements they have in common. So then you can come to what is the source of truth for that data element, which one is going to take precedent over the others, or if it's not going to take precedence, how are we going to handle the fact that we have potentially multiple versions of the same data element. So you're able to look at all of that information before you start integrating your data. If you're using something like Generate, folks have been using Align in order to be able to go ahead and map between their system and the names of the elements and then what CEDS calls it, because Generate is built off of CEDS. So understanding that helps in preparation for Generate. Then defining new elements. As we go along, as you know, data evolves, right? The need for data evolves. There may be new reporting requirements. There may be new policies, anything like that. And you need to create a new element or begin collecting something new. In that case, CEDS and the Align tool help in two ways. One, you can look at does CEDS have this data element? Just period, does it have it? If it does, you can look at the data element definition and the option set and see how that works with what your needs are for your data collection. In addition to that, you can run a report in Align that will allow you to look at anybody who has shared their map publicly and see how have they defined it? What do they call that element? So you're able to learn from your peers as well. So for Align, what does it really take to do this Align mapping that I keep talking about? The rule of thumb that we use is it takes a good solid work week, 40 hours, to align about 250 elements. So just keep that in mind as you're doing it. We often recommend that you start small, maybe a single use case or a smaller data system, something like that, until you kind of get your feet wet. On here, you see a workflow, if you will. This kind of is the process to walk you through how to actually do that data mapping. And then if you actually decide, yes, we want to do that, we do have a mapping toolkit located under resources. And I'm about to jump to Connect now, but after that, I'm going to quickly go and show you where to find these things on the CEDS website. So the mapping toolkit is split into 4 books, as you can see on the screen. And each one, when you click on it, will provide templates. It will provide instructions. It'll provide potentially who might be able to do that within your system. So it kind of walks you through all of that, including that workflow that was on the screen just a minute ago. Okay, switching to Connect. Connect is the second website tool that's available. It is a data use tool. So in Connect, you're going to have a research question, reporting requirements, whether they're federal or state, a high priority topic, something that's on your research agenda for your organization. Any of that, you go and you basically say, these are all the elements necessary to answer that question. And this is how you put those elements together. That's what Connect is. It's a way to define out and really make a plan for your research or analysis. It also supports transparency because you're putting that out there. When it comes to research, it's a way to do reliability and validity to ensure that, because you are setting up, these are exactly the elements we used, and this is how we put them together to come to the answer. It provides clarity because everything is out there, right? There's better understanding of what the data is, what the definitions are surrounding it, and how it's kind of collected. And then it promotes collaboration because anybody can go and pick up that connection. They can use it within their own data system, or if they're another researcher, they can replicate your work in order to be able to validate it. With Connect, it's a little trickier than Align. Align is very subjective, and you just kind of feel your way through, this is the element I have, and this is what it is in CEDS. On Connect, it's more of an art form. It does take about 25 to 40 hours to do a connection. Seems like it should just be really easy and just go straight through. But when you get in there and you start thinking about, okay, I really need to answer this one piece of information, I may need 4 elements to be able to pull that, to get a time period, to get a cohort, whatever it might be. So it takes a little while to think through it, even though the boxes are very easy and step-by-step to walk through. If you are moving towards that, reach out to us. We are more than happy to help you. And we can provide you a demonstration of either Align or Connect. And we can also kind of give you some tips and tricks on how to maybe accomplish these things. Okay, so for just a moment, I'm going to take you over to the CEDS website, which is ceds.ed.gov. And we are looking at Align and Connect. So under Tools, you will just go to Align or Connect. I'm going to go to Align very quickly, but they're set up exactly the same way. They're both set up with a build, use, learn concept. Build is where you're going to manage any of the maps or connections that you develop. Use is where you're going to run reports. And then learn, of course, is where you're going to be able to get to tutorials. They are video tutorials that are between 5 and 10 minutes long each, so you can get to different sections depending on what you need assistance with. Of course, under Learn for Align is that mapping toolkit I mentioned, but you can also access that mapping toolkit by going to Resources, and it's Mapping Toolkit. Now you'll notice I'm not logged in at this point. I've just gone on there. You can access all of this without an account. The only reason to have an account is if you're going to create a map or a connection, or you're going to work on, you've been assigned to one, you're going to work on a map or a connection. Otherwise, you can go and look at any of the publicly available maps or connections. You can do the tutorials, you can look at the mapping toolkit. All of that is available for free at any time without an account. Okay. Now, I'm going to turn it over to Liz Brunette, who's going to start us off talking about the GitHub tools. So Liz?
Perfect. Thanks, Nancy. Can you hear me okay?
Yes.
Okay. All right, perfect. So as Nancy said, my name is Liz Brunette. I am on the CEDS team. And the first thing that we're going to be looking at and reviewing is the Integrated Data Store, or the IDS. As you can see on this slide, we have an image of GitHub, our repositories on GitHub. We will be reviewing that in the next few minutes once we've gone through the different tools that we want to look at. So you can see you can contribute to the IDS through the OSC via GitHub. There is the link right there. And like I said, we will be reviewing it here shortly. But the IDS model really provides a standard framework for integration of P20W data systems through the normalized operational data store. And it's really used for transactional data systems to perform near real-time reporting. Additionally, it's also used as a staging area to load the CEDS data warehouse, which we'll discuss shortly. Okay, so a quick overview of the IDS. It is a Microsoft SQL database. It is used for transactional systems and integrating multiple data sets. Meaning it's really meant for managing data. It's good if you want to integrate specific data sets such as post-secondary and K-12, really looking at the cross-sections between those two data sets. As some of you may know, and probably if you joined the last masterclass, you heard about the OSC. This is really where we dig into new elements, if there's something that the community is looking for. Each of those elements is discussed and reviewed through a process. Once those elements are decided on, then it's integrated into the next major release, which is on a yearly basis. One additional thing I wanted to call out about the IDS is that it does contain all of the CEDS elements within the data model. So everything included within the CEDS model is in the IDS. And then we're going to chat about the data warehouse. Okay, so you can see on the screen, it looks really similar when you get into GitHub. Again, you can contribute to the data warehouse through the OSC on GitHub within the specific repository that we'll be reviewing shortly. So here again, a quick overview. It is a Microsoft SQL database. This is a star schema data warehouse. And it is really built out. It was really built out based on reporting, analysis, and use cases. Initially, the focus of the data warehouse was on EDFACS and Generate, but over the past several years, through the community and through the OSC, there have been additional use cases that have popped up, and the community has really built that out. Currently, there are 19 fact tables that are built out within the data warehouse, in addition to EDFACS and Generate reporting. And then future expansion plans. So we will be starting a graduation and dropout work group pretty soon. And so that really is in addition to those 19 fact tables that will grow and build upon. So we'll build those out within the graduation and dropout work groups. Next, we are going to discuss the CEDS Data Warehouse Parquet. And I'm going to pass it over to Nathan.
Hi, everyone. I'm Nathan Clinton, the principal architect for CEDS. So I'm going to talk about the two most recent additions to the CDS open source community. So the first is the CDS Data Warehouse Parquet standard. And this is a standard that we built in partnership with the Department of Education in Maine and their partner, Cedar Labs. And the use case here was really to help Maine leverage CDS in a modern data analytics and reporting architecture in the cloud. So they wanted to build off of a data lake architecture. And CDS, one of our main goals is to provide data models and resources for anybody who wants to use CDS, regardless of what architecture they're using. So we did not have a compatible data lake standard. So we introduced the Parquet data warehouse project. So to kind of give you a really high overview of what this is, I'll start with Parquet. Parquet is a file format developed by the Apache project, and it is a way to store data in a flat file in a structured way. And it's a very efficient way to store data. So think of this as like a comma delimited file, a tab delimited file, but with a lot of additional functionality and capabilities that make it very efficient, easy to use, and it remains structured, which is different than other flat file formats. So great for things like data lakes, where you're storing data in files. So that's essentially what Parquet is. It's a file format for saving data that you can use and query in a very efficient and cost-effective way. So just to give you a basic rundown of why it is different from other flat file formats, Parquet saves data in a columnar format. So if you think about a CSV, you have one line of data per, and that's one row. And you just have a bunch of rows over and over, all the way down through your file. Parquet actually saves your data grouped together by columns. So in the file, you'll see column 1 and all of the data. And I'm not going to dive into the details exactly how Parquet works, but because it does that, it's able to more effectively query the data. So if you only need 2 fields out of the 150 elements that are in that file, is capable of doing that in a very efficient way by focusing in on those columns. It also has a built-in compression capability. So you can save a lot of data in a very small file. So that makes it very scalable and very inexpensive, especially compared to trying to save similar data in like a SQL database. So there are some very distinct reasons why you would want to go with Parquet. One other note about Parquet, this particular standard was derived from the CDS data warehouse, the SQL data warehouse that Liz was just describing. So we essentially took the data warehouse, the SQL data warehouse, took each of the fact tables, so which is where you're actually describing the enrollment or attendance or discipline data, and we created an equivalent, fully flattened Parquet file with the exact same data that you would have access to in the SQL data warehouse. So that said, it is a derivative of the SQL data warehouse, and that means that they are exactly the same, just a different format of the same data model. So this means that if you want to expand, or any work that we do to expand the either of the two data warehouse models, we first do that work in the CDS SQL data warehouse. And then once all that modeling has been done in the star schema format, we then have an automated mechanism to, once it's been approved, to create the equivalent standard Parquet definitions. So all the expansion plans they follow exactly what we have for the data warehouse. So I'm going to go now into the CDS ontology and CDS JSON LD standards. So this is our latest and greatest. They are upcoming standards, so they are currently in development with the community. So if you go out to the open source community, you're not going to find it out there yet, but you should. We want to build this out in chunks, just so that you have early access. But as soon as we are good with kind of the initial release, we'll put that out there, and then you can start to see it and become familiar with it. But to give you an idea of what this project is about, it really comes in two parts. The first piece is the CDS ontology, and that is essentially a schema, but we're using a technology called the semantic web, and we're using a language called the ontological web language, or OWL. It's basically a way of describing the schema for the semantic web. And that's a lot of fancy words, but it's the reason why we chose this particular technology is because it's a very, very descriptive way of defining a data model. So not only does it allow us to define all of the elements in CEDS in a normalized way, but it actually requires us to define how each of those data elements are related to one another. So you have to define a term and a definition for each of those relationships. So not only is it just the data, the elements, but you're defining those relationships. So you get a much better understanding of the purpose and the intent of data in relation to other elements of data. So as a part of that, we will be expanding CDS pretty significantly because of all those new relationships. We'll be defining all those and adding those to the schema. Our goal is, when this is done, that this schema becomes the master CEDS schema. So all other formats of CDS data models would be a derivative of this CDS ontology. Okay, so the other half of this, so we've defined the schema and the ontology, but if you're actually going to express data using that ontology, we are looking at JSON LD. So JSON LD is at its core just a JSON data, which is a way of representing data in a textual format. You can actually pull it up on screen, you can look at it, and it's formatted in such a way that you can read it. But because of that, it's a great way to move data for use cases like web APIs. So if you're using web APIs, web services in your architecture, this is a good way to use JSON and to implement CDS in your architecture. It's also a great way to save data to a data lake. So you can actually take your JSON LD documents and save them as files directly to a data lake. And then I also want to talk about the LD part of JSON LD. So you may know what JSON is, but the LD piece stands for linked data. And this is a bit of a twist on kind of the normal JSON. And it really allows us to bring in that relational component of the ontology into a JSON implementation. And so with linked data, you can define values for CDS elements as either kind of the traditional data types, numbers, texts, option sets, true, false, all those things that we're familiar with on, we live with on a day-to-day basis. But it can be a URL as well, meaning you can create a reference in your data set to another data set, and you don't have to define it there, right? You don't have to actually say, for instance, if I have a set of student attendance history information or their enrollment data, you can provide, when you reference the school, it can be a link to a location, be that another endpoint or a file, some resource out on the internet that defines that school. So really what you're doing is you define the pieces that you want to deliver in your JSON document, and anywhere else where you don't want to have to bring that data in, you can just provide a URL where the person can then actually go off and find more of those details. Of course, given that they have the proper security rights. You can even use linked data to integrate data from other systems. It doesn't have to be CEDS data. Really, it can point to any other data resource that can be out on the internet. So that's the power of linked data. So going to our future expansion plans, the initial release that I mentioned earlier, we plan to have out in February of next year. And it will include the directory model, so schools, organizations. It'll be across the P20W spectrum for directory. We'll have K-12 student, which includes enrollment. We'll have discipline and assessments. That'll just be the initial release. And then once those are out, we'll be working on individual components. And as they come out, they will be released as part of the open source community repository. So you can go out there and participate. As they're being released, you can go and start leveraging those schemas and making JSON LD documents. One other note about that, if you are interested in joining the work group, you can go out to the CDS community, open source community, and you can actually join that work group. It's open to everybody. We love to have more people. More people just means more thought and a better model. So please join us if you're interested. Okay, so from here, I'm going to take us out to the CDS open source community and give you kind of a quick tour through the website. So URL to this is github.com/CED standards. It's not CEDS or CDS standards, it's CED standards. We had shown some graphics of this before, but these are the 5 main repositories that we have available out on the open source community. So the IDS, the elements where we actually define the data dictionary, the collaborative exchange, which is a place to share code or resources, reports, tools that are developed, the CDS data warehouse, SQL data model, and the CDS data warehouse Parquet data standard. So for each of these, Nathan, we have a very...
I'm sorry, real quick. So for the group, do they have to have a login in order to access this?
You do not, no.
Okay.
This is all open source, so it means it's freely available to anybody who wants to come out, download these. They are all under the Apache 2 open source license, which is a very liberal license, meaning you can download it and essentially do whatever you want with it. I would recommend you, if you are planning on using it, that you go out and do some studying on exactly what that means. But we wanted these resources to be available to agencies, to vendors, anybody who wants to be in the CDS space. to be able to use these for their projects. Really, I mean, the goal here is to have common definitions, and these are all tools that will allow you to join that CEDS standard and express your data with those standard definitions. So I'm going to hop into the CEDS IDS and give you a quick walkthrough of each of these. The most important piece as you come into each of these repositories, if you scroll down, there's a README file, and it talks about what the project is, where you can find more information, and we have quick little guides, how to get started, how to do upgrades, how to load all these resources and leverage all these resources. We also have instructions on how to submit a use case. So if you'd like to contribute to, or at least report an issue, or say, hey, we want to address this new need that we have instructions on how to submit that request through GitHub issues. We also have a contributing guide for each. So if you actually want to, for the code-based system, so the IDS, the data warehouse, Parquet, JSON, collaborative exchange, if you want to provide code, we have a little guide that describes how you can submit actual code to the open source community. We talk about how we do versioning, so major and all the way through to the minor releases of each of those solutions, and what's included within each of those kind of subdivisions of those version numbers. And then we have documentation, a link to the Apache license, so you can go there and just read that, and it'll tell you, in essence, what the Apache license covers and how you can use it. So the actual folder structure, the content of the repository is, again, the same between each of them. You have a doc folder where we have all of our documentation. We don't really need the ETC. That's kind of just where we have some of the back-end administrative stuff for the project. Resources for things like images, and then the source folder where you would actually go to download the code, the data model, to implement it on your servers. I'll start by going into the docs folder. For the IDS, we have several documents here, and these are very, very useful documents. The first set are change logs. So between each minor version and major version, we put out a document that says, here are the things that we changed between versions at a column by column level. So you can actually see this column was changed in this way. If we renamed it or moved it, you can see where it was in the previous version and what it is in the next version. The conceptual model is just a very high overview of the IDS. Very handy if you just want to get a quick overview and an understanding of what the IDS is, how it was developed, kind of what were the design principles when it was developed. And then I would say the most useful document is the data model guide. So it takes the conceptual model and then actually it takes you down to the next level of detail. So you can, if you really want to know how to use the integrated data store, this is the document that will kind of train you up on exactly how to use it. The IDS preferences is just another really good document that provides more detail into the actual the columns and whatnot, the definitions, how the CDS elements are linked to the IDS. Okay, so I'm going to move over to the data warehouse. Again, same structure. You have a README document down below for how to get started, how to upgrade, how to contribute, versioning, so forth. Same document structure, but I'll go through the documents here because they're a bit different. Again, we have the version upgrade information, so you can see the comparison between the previous version and the current version. Here, we don't have the data model guide, but we do have a data warehouse bus architecture. And this document is very handy for understanding what all the fact tables are. So essentially, what capabilities do you have for reporting and analysis? A definition for each of those tables. What dimensional data is in each of those, and what the grain is for each of those fact tables. And the grain defines what constitutes an individual record. So this is a very good way to get a good understanding of what data is in there, what it means, how it's defined, and how you can use it. If I go into the source folder, we have two folders here. DDL stands for Data Definition Language. This is where you'd actually go to download the model itself if you wanted to stand it up on your SQL server. It's a SQL script that will stand up the database and allow you to start using it. The dimension data folder here contains scripts that will fill in all of the dimension tables with the CEDS data elements. There's an equivalent of this for the IDS as well. That allows you to load all your reference tables, all your lookup values, so that you have all the CDS elements essentially kind of pre-pop. And the Parquet, again, standard information. This one has a couple different folders. So this one doesn't have a source folder because it's not a data model that you stand up in a server. It's a serverless tool, right? We're essentially defining the standard of a flat file. So rather than having a database that you stand up, we give documentation on what would go into the Parquet file. And that's defined in our docs folder. We have a definition for what goes into each of those Parquet files, column by column, and you can see the definition, the data type, and all that. So this is, in essence, the standard, the data warehouse Parquet standard, this document right here. We also have a little tool that is written in Python. If you have a SQL data warehouse already stood up, a CDS SQL data warehouse, you can use this tool to create take the data you've already loaded into the fact tables and create Parquet data from that data warehouse. We leverage this to create tests. We also use this as the tool that allows us to automate the standard of that Excel document that I showed you just a minute ago. So we run this against the data warehouse, and it just spits out an exact Parquet version of the data warehouse that we copy into that Excel document. So the turnaround from completing and approving a SQL data warehouse change to be able to have a Parquet equivalent is very, very quick. We run this little app, and then we have the new standard available. It comes with a series of views on the data warehouse that essentially just flattens out each of those Parquet or those fact tables so that you can even see what the equivalent would be directly on your SQL server if you want to do that. The development of these views is even automated. So yeah, it's a very fast way to get this documentation out there, but also a very useful tool if you want to either convert from the SQL data warehouse to Parquet or just produce Parquet files from your data warehouse. This Python application will allow you to do that. Okay, so I think we've covered the open source community, and I'll go ahead and pass it on to Dwayne.
Great. Next, we're going to take a look at some examples of some implementation options. I'm going to start out first by sharing some basic diagrams and explaining some example use cases. And then after that, I'm going to turn back over to Nathan, and we're going to look at some examples of enterprise architecture models. You can see where each resource fits within the architecture itself. So the first one we're going to look at is the integrated data store. As was mentioned, it's Microsoft SQL. You can basically download the code from the open source community if you have SQL installed, and have the database, the integrated data store database, installed in less than 5 minutes. It's really fast. You have it there and you can begin to work with it. So let's talk about ways that we can actually utilize it. It's highly normalized, which means data are generally listed one at a time. So one record at a time in the database. So you would only store the person's first name one time. You would store their birth date one time, your address one time. And in order to do this, all the data are separated into various different categories. So you could think of different buckets to put the data in. And those are joined together through keys that let you join the data together. So a person exists, over here an address exists, and those are linked together through keys. And the reason why they're separate is there's one person who may have 3 addresses, a work address, a home address, a mailing address. And so there'd be a key linked at for each of those different addresses to that one person. So that's what normalized basically is creating those categories so you only list everything one time. What this is great for is transactional use. So inserting, updating records of information. The first example I have listed there in the middle is a directory management system. So let's say you were a state education agency on the call and your LEAs provide information to you related to the opening and the closing of schools. They'd also provide address information for those schools. They provide the school's name. They provide the grades offered. They may even include facility information about the schools, the buildings that they have, that sort of thing. So in a lot of states, districts would log into a portal of some sort, and they would fill that information into some type of portal login and type that in and key that in. They may also send it electronically through spreadsheets, that sort of thing. That portal, though, that they would be logging that information into, that could sit on the integrated data store. So that could be used as the foundation for that type of system. So a data entry collection of data is where you're looking for that integrated data store, that transactional use. Other examples I have there are credential management or competency management. So if you think of keeping track of the certifications or the credentials for a person, teacher, various different others that would have to have certification, superintendents, principals, and managing all those, they may have to go in, they may be logging in to add in the schools that they attended, their years of service, previous years of service. That's like one record at a time. It's one person entering that kind of data. Again, the integrated data store, transactional, that's what it's great for. You may have also a competency management system where you're listing all the competencies or keeping track of those. Also may be known as learning standards in your state, where you keep track of all your learning standards. A lot of times these are sitting inside of PDFs, which makes it difficult to pull out and utilize. So getting it into a data model like this, where you can update those over time and keep track of those and versioning, it's what this integrated data store is for, right? So those various different transactional records, one record at a time. The fourth example listed there, a little slightly different, is systems integration. So when you think about having multiple sources of data coming together at the record level, and you want to integrate that data coming together, that requires first some governance, where you're looking at that because there's potentially conflicting sources of the truth, where you may have student data over here and student data over here and student data over here. But the IDS provides a way where you can integrate that data into a standard single structure that you can then utilize to move forward or do various things with that. So that's the integrated data store. Summing up, if you think of the integrated data store, what I want you to think about is it's really one record at a time. So working with a single record of data, that's the integrated data store. On the opposite end of that is we have the data warehouse. So the purpose of the data warehouse, instead of thinking about it one record at a time, think about the data warehouse as 1,000,000 records at a time, which is a lot of records to think about. It's not well suited for data entry or that transactional, but it is well suited for analytics and performing calculations quickly. So when the question comes up, how many students XYZ, how many schools XYZ, you're really looking at the data warehouse to assist you in answering that question. You can see the arrow from the laptop pointing out only. On the other screen, it was pointing both ways, data entry in, data out, so you can be updating records, really just pointing out. It's great for data out, not so well suited for data in. On the right side, there are sources that would be integrated together to feed data into the data warehouse. One of those, little tiny one, the green one right there, that could be the integrated data store. So if it's capturing student level data or you've integrated data together at the record level, then that may be one thing that's going to be feeding your data warehouse. Your directory management system that we talked about that runs all the schools and has all of that particular data. If you were going to do an EdFacts report like directory or grades offered, you'd consume that into your data warehouse. And also it could be the source of all truth for school information. that would be loaded and linked together to other sources to bring that data in. So the reports that you'd want to run those out of the warehouse. You can try to run things sometimes out of the IDS, but it's difficult to join together millions of records. It takes a long time. So the purpose of the warehouse is to speed up that kind of reporting. And the examples we have there, state and federal reporting. So you think about a common state level report, such as average daily membership and average daily attendance, and just think about the complexity of that. There are sums of counts of large numbers of students related to the days they were enrolled or attending. So if I say sum count large number, you say data warehouse. That's what it would be used for, is the ability to count those things quickly, to add up all of those average daily attendance, average daily membership, that sort of thing was what you would use a warehouse for. So the data are stored in that in such a way that summing and counting occur quickly. The time to load the data, that could be large. So you think about loading the warehouse, that can take some time because it's grabbing together all those sources, flattening it out, and getting that data into there. But the ability then to slice and dice it can occur rapidly. So you can ask a lot of questions and you can get the answers quickly out of the warehouse. Data warehouse loads do not typically occur frequently. It's usually when you have a full set of data to load. Other examples I have there include dashboards where you're displaying counts. One example of that could be a school report card. So you would have counts of school report cards, these schools, and how many students do they have, and information related to finance and information related to assessments, that sort of thing, where there's a lot of counts. On data warehouse, you'll often see business intelligence tools placed on top of that. And then finally, it's also a resource that would be used to answer research questions. Since the data in there are generally already clean, it's where you pull all of your other data. It's the source, and grouped in ways that make it ready for answering questions. The CEDS data warehouse has two components to it. It has one where it has the student level, so the record level data, but stored by facts, so that if you want information about that particular fact, you can query it quickly. You can get counts quickly about certain facts. And then it also has a semantic layer where you can store data at the actual counts themselves. So you think about the EdFacts reporting, there are actual counts that have already been pre-aggregated and stored. So a researcher coming in to make use of that would have access, again, through governance and privacy and FERPA and all those things being kept, would have access to either those student level records where they could run and do some analysis on that, or those aggregates that have already been pre-created. So that is the data warehouse. So think about a lot of records there. Okay, another resource that was talked about, which I won't go into in great detail as far as examples, was the Parquet version of the data warehouse. You can see the screen, nothing changed really, except for the addition of a cloud and some dollar signs. The Parquet version of the data warehouse does essentially the exact same thing as the SQL version. But as Nathan was pointing out, Parquet being an open source standard, well-suited structurally for the cloud, it reduces the cost of storage. And it can also be easily integrated into various different clouds like AWS or Azure. And you also have the advantage of the licensing in relation to like not using Microsoft SQL. So just provides another way to structure CEDS data elements and to make it take advantage of a data warehouse structure, but in a way that is more flexible in a cloud environment. And then finally, we have the CDS ontology, which, as was mentioned, was in development right now. We have a group, as was put in the chat earlier on, meets every other Thursday, and we'll actually be meeting this afternoon. We're going to be continuing a discussion on assessments. If you happen to be interested in joining, you don't have to participate directly. You can just be there to listen. So all of the CDS work groups are open for anyone to join at any time to contribute or to just listen in and learn. You can learn a lot about CDS just by listening into various different work groups. So welcome anyone on that call. Welcome to join this afternoon, or we meet every 2 weeks. So the ontology connects everything together, basically. And we're developing a CDS ontology, which will link all of the CDS elements together in a large picture. So if you can think about this links to this, to this, to this, to this, that's what the ontology is going to be able to do. Purpose, so we can see how all the elements interact, and then the ability, of course, to then express that interaction in multiple formats. OWL is what it will be built in, but you can express it in JSON LD, XML, RDF. So various other standards that you'd be able to express that in. By developing the ontology, we're creating that flexibility that cannot exist if we were to only target one of those particular resources. Like if we just went with JSON, then we'd also have to build XML, but by building the ontology, we're going to make it so that it's flexible enough to create the other resources as well. It also allows the implementation of the ontology in those formats to have flexibility in how they're used. So the core of it is still the CEDS elements. The core of all the resources that we've been showing you today is, of course, the CEDS elements and their vocabulary, their definitions, their meaning, because that's where the real value is. But in this ontology, we're getting a little deeper. So we're going to be defining more than just the elements now. We are actually going to be defining the relationships that exist between the elements. And that's what gives that ontology that flexibility. So if you think about a student, we can define what a student is, a person, a first name, that sort of thing, and a school. But then we have to also define the fact that they're enrolled in that school. What does it mean to be enrolled, right? So on the ontology, we're going to actually be going through and looking at some of those connections between that and defining relationships as well, which will broaden CEDS definitions and language into that ontology. On the next slide, we're going to take a look at how this will be used to connect those CEDS resources together. So the ontology here is represented basically by the CEDS logos all over the arrows. As it's completed, we're going to have the ability to use it to transport data from one system to another. A user entering data into a computer, for instance, that could then be formatted as JSON, JSON LD to load the integrated data store, if that would be the use case. Data could be transported out of the integrated data store and able to load the data warehouse, again, using the ontology, expressed out as JSON, JSON LD, XML, whatever ends up needing to be created for the actual movement of that data from one resource to another. Various different data sources on the right could express their data out as CEDS to load either the integrated data store or the data warehouse. The ontology itself, as you see kind of the arrow pointing to just itself, to an ontology, it also could be used as a storage model. As Nathan was mentioning earlier, the JSON LD can be brought into the cloud and stored in that way and queried directly. So all of it basically depends on the use case. The purpose of the ontology is not to have to know all of the use cases, but to have a core foundation built, and that's what the ontology is doing, and that we're working on. So in the examples I mentioned, data transport, but to be more specific, the ability to move EDFI, A4L, PESC, other standards into the CEDS environment is one real world use case that is part of the reason why we're doing this. So as an example, we have a state right now, or several states right now, that have EDFI ODS with that data, and they want to move that data into the CEDS data warehouse. One option we have would be to write ETL code to do that, but that assumes we're always going from the EDFI ODS to the CEDS data warehouse, and we have to write the code and maintain the code that actually works with those tables from EDFI ODS to the CEDS data warehouse. Well, we also have states that want to move data from the EDFI ODS to the CEDS IDS, the integrated data store. Well, that would require a different set of ETL to be able to do that, which would be specific to those particular tables. What if in the future they want to move it to the Parquet warehouse? What if they want to move it to a graph database based entirely on the ontology? So the solution that we're looking at here is to express the EDFI data as a form of the CEDS ontology. And once it's in that format and structure, we can then take it and move it to one of the other resources as we build those arrows between the various different CEDS resources and how they connect to that ontology. It's just the one point that you have to manage as far as coming from other systems is through that CEDS ontology. So it essentially becomes the gate to get into the CEDS environment. And once you're in that CEDS environment, then you have the resource then to move between the various CEDS structures. So I'm going to now hand this over to Nathan to take a look at some ways these could be modeled out in an enterprise architecture.
Again, everyone. Okay, so we're going to go through a series of diagrams. These are very busy, very technical. We'll go through a on-premises implementation. We'll go through a couple cloud implementations, and we'll also look at Generate, the architecture for Generate. So these are really meant to just provide examples of how you can build a system many different types of systems, how the data might flow through a full end-to-end architecture. And these are not meant to be prescriptive. This is CDS. We want to be there wherever you are at, whatever kind of architecture you have. So these are meant to give you an idea of how the various CDS resources can be leveraged in your architecture. So we're hiding most of the diagram here and the others so that we can go through this kind of piece by piece. So we'll start with a state on-premises implementation. So you may have something like an Angular web application that provides users with an interface to enter teacher certification or directory management data. Again, using those as examples. A user logs into the system and then interacts with a web server that allows the user to retrieve data or save data. So that interaction with the web server is done, can be done with CDS JSON LD. So think of a web API. So if you have an interface and you're collecting directory data, you could package up all that directory data into CDS JSON LD document and send that directly over through the API to the server. And the server can do whatever it needs to do with it, right? It could save it off to the SQL CDS IDS, if that's the technology you're using on the back end. Or it could just save, if you're using that JSON LD, you can actually save that document directly off as JSON LD to a JSON document store, something like MongoDB. So this is really meant to kind of cover the transactional use cases that you might see in your day-to-day work. And then if we go into the next section, this is where we introduce your reporting data platform. So this is essentially what we're doing with Generate, and we'll get to that in just a minute. But this is the SQL data warehouse, CDS SQL data warehouse. The use case here is you would take data from those transactional systems and move that over into the CDS staging environment, which is part of the warehouse. It's a low barrier way to move data in, make sure it's valid and ready for reporting. And then once you have it in staging, you can move that data directly into your warehouse. Once it's in the warehouse, you then are able to do all of your reporting and analytics directly off of that. If we go off to the data governance platform, you can integrate, if you have a data catalog or a governance tool, you can catalog your warehouse and you can work through any of your data governance issues. You can use the catalog as a way to understand your security and privacy profiles. Very handy tools. You can also leverage the CDS Align and Connect tools here as a way to understand how CDS, if you lay it over other tools, how allows you to kind of start using or integrating CDS terminology into your day-to-day conversations, right? So if somebody says enrollment, everybody has the same understanding of what enrollment is. And then the last square is the business intelligence platform, where you would bring in your BI reporting tools, analytics tools, something like QuickSight or Power BI or Tableau, Excel, whatever kind of tool it is you're using. You can take that tool and plug it into your data warehouse. That's what the data warehouse is designed for, right? Is for doing data analytics and reporting. So you can do that, grab all your data, shape it into whatever format you want, do all your aggregations, and make that whole process consistent, easy, and efficient. So one implementation of this is Generate. When we designed Generate, we wanted to kind of meet state education agencies. That's kind of the where they were at. In most cases, I was still on premises, so we built we used that on premises architecture. So at the very top, you'll see kind of two components for the Generate web application. One is the the user interface side, and then we have a background application that handles all the long running jobs, like all the data processing on the back end. But again, it's the same thing. You have Generate's built on an Angular application. It interacts with a back-end web server, and that web server, we actually have a couple application-specific kind of tag-along pieces for what we call toggle, which is like your edfax metadata. And then we have all the file specification information that we store in there as well. But really at the core of Generate is the CDS staging environment and the CDS data warehouse. The same version that you can find out on the open source community. So a state would take their source data, integrate that in using ETL into the staging environment, and then use the Generate tools to process that and create, move it into the data warehouse and create the edfax reporting outputs, the actual files that you take out of Generate and submit to the edfax website. So now we're going to move on to cloud implementations. So again, there are a lot of different ways that you can implement systems in the cloud. We went for a kind of a best practice managed services approach. So kind of the more low overhead options. So it's kind of based on the current best practices. And we have one model, one for Azure, and then one for AWS. And we'll start with the Azure one. So again, this bucket is going to look very similar to the last two, right? It's an Angular application, but you would put the JavaScript files up on an Azure content delivery network to actually make the web application accessible to the users. It's essentially the same thing. If the user gets the Angular application, that's how they interface with the backend data stores. Same concept as last time. If a user is saving or updating data, you can pass that information along to a web API in CDS JSON LD format. That will then go through an Azure API management services, which handle all your security and API definitions and all those complex API components, and then pass off the JSON data off to Azure functions. So it's a serverless way of writing code and interfacing with your data store. That serverless function that could save it off either to the SQL IDS or again over to Cosmos DB, and essentially the JSON data store where you could store the JSON data directly. It's almost exactly the same, just with cloud components in place of the on-premises components. Now we're going to go on to the data lake, which is where things really begin to differ from an on-premises. So in this case, the data lake is really about being able to quickly and easily integrate all your data. If you are implementing CDS, of course, you are going to want data to standardize on that in those formats. So we have the tools again to be able to do that here, and this is really where the JSON LD and the data warehouse Parquet really begin to become very powerful tools in your toolkit. So starting on the very, very left, if you're pulling data in, just raw data from EdFi, CIF, your SIS vendors, whatever, you're bringing that in CDS JSON format, either through a streaming platform or just directly into your first bucket in your data lake. That is kind of the first step of a data lake architecture. Right? Just get all of the data into the data lake, and we would call that your raw zone. From there, that's where you begin to really process the data. You do all your data quality processing. You begin to catalog all of your data. You do all your complex business rules and your integration through tools like data factories or Synapse pipelines. That data will then land in a managed zone. And this is where you would first introduce your CDS data warehouse Parquet format. But you're actually converting it to a format that is useful for reporting. Once you have it in that format, then you can do additional processing, right? Like if you need to make some pre-processed data for specific reports, pre-aggregations. You can create those files, and you can also just copy over the raw data directly into your published zone. Right, so this is kind of the final step in your data lake. The data is now available for people to do data governance and also do their BI work. So on the data governance side, Azure has a very powerful tool called Purview. If you could click the, thank you. So Azure Purview is a data governance tool. Allows you to catalog all of your data and run it through all of your data governance processes. So CDS ontology here as a data dictionary can help you create classifications on your data elements in Purview so that you know what data you have in your data lake. You have the CDS data dictionary there, so you have all the definitions and everything available to you. So this is one way to really thoroughly adopt that CDS data dictionary and start speaking the same language. Your data, you can then start using your data in your BI platforms. So in the cloud, there are a lot of different options for BI, right? You could go directly into on Azure, right into Power BI to do your analytics and reporting, or as an alternate model, you can stand up the SQL data warehouse on a modern data lake platform, like the full star schema using Synapse, Azure Synapse. It is the kind of their modern data warehouse tool, and it's compatible with the CDS data warehouse star schema, the SQL data warehouse that we have out in the open source community. So you can implement that in Synapse and just use the data warehouse like you would on premises. So you have options there in the cloud. So on the AWS side, it's almost exactly the same architecture, but we've replaced the component tools with the AWS equivalent of those. So in this case, you have an Angular application offered up on CloudFront for your content delivery to get the static JavaScript files out to the user. Data is coming in from the platform API gateway into Lambda serverless functions, and that's being saved off to a relational databases or to DynamoDB as your JSON document store. And then again goes into your data lake. Lake Formation is a great tool that you can use to save your data or kind of build your data lake. Goes through the same process, just using the AWS tools into AWS Glue catalogs, and then up into QuickSight or into Redshift. Redshift being the equivalent modern data warehousing tool where you can use the CDS data warehouse. So now let's pass it over to Emily.
Thanks, Nathan. No small amount of information there. So we're going to take some of that information and turn it into how do we solve some of the common problems that we hear from different stakeholders with some of these tools we just talked about and learned about. So I'm going to go through a couple of sections of different examples of common problems with new or existing data collections, and then we'll talk a little bit about some data governance options as well. But I'd invite all of you, as you are, as you've just listened to this, to enter in any additional kind of common problems or something that you might be thinking that CEDS either you think could solve or has solved for you as we go through these. So happy to have you enter those into the chat, as well as any questions that you might have. So I think kind of on the simplest, or maybe the entry place for a lot of people into CEDS and thinking about how it could help solve new or existing data problems is leveraging the elements tool, right? So consistency and definitions whether you're a local education agency, an organization that's providing educational services to a school or to a district, whether you're a state organization, a P20 organization, or a higher ed education agency. All of the different domains of data within CEDS, as you're looking for common definitions or redundancy within your own collections, starting with the elements can really be helpful in identifying what is the national standard. How have national stakeholders and peers in my group defined this element? Could that help provide some clarity to us in our definition? Maybe we want to adopt the CEDS element definition to create some clarity. Another way to see that is, of course, to leverage the align tool. The align tool where you can take your own systems, or maybe you have your system and multiple stakeholder systems or definitions, and align those to CEDS to see where those things cross or don't cross, and how well those definitions seem to make some sense. The other thing that I think in terms of like new or existing data collections is around, knowing if you're collecting the right elements for a particular, like a high stakes or a critical policy question, or for federal reporting. Certainly Align and Connect are the place to help you identify that, or to help you gather some information. For example, existing connections that are out there, so kind of the business rules of how to create the EDFACS reports are available in the Connect tool for CEDS. And if you've done your align mapping from your systems, you can see how well that makes, how well that actually correlates with the way that you currently produce your EDFACS files. So if you've got your elements aligned, you can look at how those connections, or how you're aggregating, how those aggregations would occur, say for EDFACS reporting, or potentially for other critical policy questions. You can leverage that Connect tool to help inform where those definitions, or where the elements that you're using do or don't make sense to you and to multiple stakeholders. The other useful resource from CEDS that you might not think about when you have a challenge or are looking to collect new or existing data is to leverage the open source community. Maybe you've gone out to align, maybe you've aligned your data and you've gone out to see how the definition in CEDS exists for a particular element, and you're not really sure how closely that makes sense for your potential use. You could leverage the open source community to find out, like, who else, leveraging the align tool to find out the other element maps that people have created for that particular element. Maybe you contact them. Maybe you start a working group to help, create some discussion around a particular element or a particular area of data that your state is, or your organization is maybe leveraging in a different way. So another kind of topic area is around integrating data from multiple systems. So we just heard, of course, I have to mark the physical data model, of course, is a great option for helping to solve some of these challenges around implementing Generate, integrating data for EDFACS reporting or other state or federal reporting, or of course, the big one, rebuilding a statewide longitudinal data system, or really any longitudinal data system. You might leverage that physical data model. It could be that you guys are moving, that your organization is moving to the cloud, and you want to take advantage of some of the example architectures that we just saw that Nathan provided to us, whether that be the Parquet file structure in order to reduce the storage space that you're using, whether it's just looking at the star schema fact and dimension tables to help you understand better how the national standard and other stakeholders are sort of architecting their warehouse in terms of being able to answer those critical policy questions. Another great example of integrating data or thinking is around security and privacy standards. So something that doesn't always get brought up to the forefront, but a place that CEDS can be helpful. And we actually have an example that was used by a state. If you are combining multiple data sources or integrating multiple data sources, it can be really tricky to maintain the security and privacy standards that you need as you start to combine those data sets, right? So maybe the data from one system has a much lower level of security because the data is less unit record, it doesn't contain student level data. But as soon as you combine or integrate that data with a system that does have PII or protected student data, instantly you come to this security and privacy conundrum of how do we make sure that we're maintaining the same privacy and security standards. So, and as for privacy like laws and rules, you can use Connect to sort of help manage this information. You can use Connect to sort of establish what level of privacy is required for each and every data element within the system. So I know that Nathan did some work on this for Washington when he worked in the state education agency. Nathan, do you want to speak for just a moment about your example in Washington and how you leveraged Connect?
Yes. We have in Washington State requirements from the Department of Information Technology to classify all the data that was stored within the agency. So what we did was we took all of the elements in CEDS and we used put them into 4 buckets. And those 4 buckets aligned with the security and privacy classifications that were designated by the state. So it was essentially ranging from, open and public data all the way to highly confidential, student PII, that kind of information. So we took every element in CEDS and put it into one of those 4 buckets. And then once we had those connections ready, we took all of the kind of the core applications, data systems that we had, ran those through the Align tool, so we could keep track and much more easily what data systems had private data. So when it came to our auditing time, rather than having to every time just kind of keep track in various Excel spreadsheets or whatever, where our private data was and what that data was, we could just come back to CEDS, apply the Connect tool over the hub of our alignment maps, and see how each system was classified in terms of privacy and security requirements.
So cool. Such a great example of a way to leverage those 2 tools in conjunction with each other to help identify the privacy and security. So not an example we typically necessarily think about when we think about the Common Education data standards, but another way. Maybe your organization has specific categorizations of data that you need to see across systems. Maybe it's not privacy and security, but something else. You certainly could leverage that same process to help solve or help keep track of those needs and understanding that information. In thinking about managing data governance and data stewards is kind of another key place for CEDS to be helpful. As a former data governance coordinator, I will just tell you that I think that there's a lot of opportunity that could be leveraged in trying to help data stewards, whether, again, at any organization level, have the knowledge to be successful, is by leveraging Align and the metadata or the data governance pieces of information about the elements as you align your own source elements, but being able to track who the data steward is, when it was last updated, just that general metadata of your information can be really valuable and really powerful to share not only internally to your own organization, but again, as Nancy mentioned earlier, your Align maps, you can share that more detailed information, with anybody that you select that has a user account in CEDS. So it doesn't have to just be your own information, but you could share it with other folks who need to know that information. Identifying proper stewards is a key component of quality data governance, and helping them keep track of the data elements that they're responsible for is easier said than done. But by assigning those individuals to each element, which is a data governance best practice, and you can keep track of that in Align. You don't have to pay for a different tool. Again, it has, CEDS is going to have some basic metadata that you can start leveraging right away, and it doesn't cost anything, which could be really valuable to organizations that maybe don't have the finances to include, some a fancier piece of software. The other piece that can be helpful with, again, is state staff turnover, and as they change, you can have a single source of truth about who your data governance, who your data stewards are, what elements you govern, and of course, the best way to do that is through documentation. So Align can track that information. The last piece, I love this. I need to track why we collect these elements. You can put that information directly into Align for each element that you have aligned to in CEDS. So really a fantastic way to keep track of the why. And again, you can share that information. So maybe you extract that Align mapping and share it with your LEAs every year to say, this, as a state organization, this is why we collect each one of these elements, LEAs. This is the value we use it for. And being able to provide that to them and share that with stakeholders also could be very powerful. So lastly, helping stakeholders use data. Oh my goodness. Well, I think the biggest, defining reporting requirements is really resource and time intensive, right? You can use Connect to see what other organizations have done. You can apply it to your line map to see if what you have, so again, your source information has already been mapped to CEDS, and you can apply Connect to that align map to see if what you have will answer that research or policy question. You could even leverage connections as a way for external researchers to send you their data requests, right? If you've aligned all of your source systems and you have a research request process, why not leverage CEDS and point external data requesters to CEDS and say, if you have data that you want to use from our organization, request it by creating a CEDS connection, and then we'll be able to easily tell you using our Align map what data we have available to help answer your research question or your research needs. A super powerful way to, again, maybe replace or eliminate those SharePoint lists or those Excel documents that you might be using currently to track those data requests, or the other infamous way that we often get data requests, of course, are via email. Like, I have this question that I want to be able to answer. Wouldn't it be nice to have more detail, right? To have more information. If you can point folks to the Connect tool, say, create a connection to tell me, the details about the specific elements that you need and how you're going to use them. And then I can easily tell you what we have that would align for your connection, right? I can go look at my align maps and tell you what we have. I'm going to say that maybe the other place where, again, I want to kind of point out that, like, the open source community can be a resource. So reaching out to peers and others in the community, maybe it's having a conversation with some external researchers that you can connect with from the open source community about how they, how they leverage the connections, or what are the types of ways that they request data, could be really helpful. You can use in as far as the SLDS for EdFacts reporting. Again, all of those connections, along with other connections for CRDC and IPEDS, are all out in the CEDS connections list. And you could use MyConnect to apply your SLDS map from your own system to the EdFacts file specs to show you what you already have, right? Same thing for Generate. If you're a state that is interested in using Generate, the first step is aligning your source systems that you use for EdFacts reporting to the CEDS to elements, and then you can apply that align map using MyConnect to see what elements you already have or which ones you might need to find new sources of information for. And so it really can be a catalyst for starting your journey into Generate. I know that many of you probably have other challenges. And again, if you have things that you're interested in that you didn't see here today, or you have some questions, please reach out to us. We'd be happy to help you identify ways that CEDS could help you with either your stakeholder use challenges, your data governance and data stewards challenges, data integration standards, data integration challenges, or new data collection challenges. So please don't hesitate to reach out, and be happy to give you specific help.
Thank you, Emily. I know we are at 1 minute left, so I am just going to say, if you have any questions, please reach out directly to the CEDS team. Dwayne has dropped the URL to CEDS in there, as well as we have an email address, ceds@ed.gov. So you can email us there. Either way, you can get in touch with us. I do want to very quickly just point out that we do have one more masterclass. This is CEDS IRL, or in real life. I'm dropping in the chat now how to register for that. It will be next Thursday, where we will have Michigan and Mississippi are going to talk about how they have been furthering CEDS through their efforts. So we hope you'll join us for that. We do want to thank you for joining us today. The contact information and URLs and everything are on here. In addition to this, we have put together a CEDS resource document to give you all of the various links that we've dropped into the chat today. So let me just drop that in very quickly for you, so you can go access that resource document. And want to thank our presenters today. So we appreciate that, as well as your attendance. Thank you very much, and we look forward to seeing you next Thursday.